Markus is probably the one who comes the most farthest area from north, I think, during this conference.
So, not
so
the distance, but yeah.
Yeah, he's living together with ice bears and, and walks only.
Occasionally we have a moose that we see, but ice bears.
Yeah, Markus is giving us insights about better ways to write tests.
Test tools.
Test tools. And IoT is also the topic.
Yeah, but it doesn't really matter. But it's based on my work there, yes.
Okay.
Yeah. So if you was here last year, then I did a talk on the testing frameworks and how to do the testing. And I show some of that here, but then this year I'm going to talk how that evolved.
Okay, great. Then you can get the clicker and I will prepare the screen so you can start.
Yes, let's reset the timer.
Your talk, yeah. Okay, good
All right.
luck.
So, hello, thanks for joining after the lunch. I'm gonna talk about my journey into being not happy with the tools that I use to test the software, and then, eventually writing my own test runner that fixes the problems that I need. And I want to inspire you to tinker with the tools that you have and not take what you are given because, this is the framework that we use for this language. So, let's start. I'm Markus Tacker. I'm a German living in Trondheim in Norway. I work for a company called Nordic Semiconductor, which you probably haven't heard about because we are a hidden champion and we are in a lot of connected devices. So if you have a wireless keyboard from Logitech, there's a Nordic chip in it. I work on the IoT part, meaning we also have a long-range chip that connects to your sensors to the cloud using the mobile phone network. And in that area, I'm responsible for developing cloud-based software. You can find all my links on coderbyheart.com/socials. So, the context, as I mentioned a bit, is because I work with AWS and Azure, and use serverless services there, like AWS IoT. That's a service that you cannot download. There is no binary that you can run it locally, like your Postgres. And so there's no way to really mock that or have it as a stub that you use to write your test. So I have to write tests against the real thing in the cloud, which then is an end-to-end test. I stick some data in here and then have my backend logic do something and then I expect a result. And I was using Gerkin for that, and this didn't make me happy because there were so many limitations that I encountered, and I'm gonna talk now about what these things were, and maybe you find that that's something that you can also recognize, and then we can see a bit how we can approach that. Need one, improve that. There will be a need two, because I'm also not only concerned with testing the software, I'm actually a software engineer, so part of my job is also to understand the software and make it understandable for my team so they can build new features on top of that. So testing is always a form of documentation, which is super important. But we have more needs than just good documentation of tests, but also how to understand the system. And the test runner can help us with that as well. That's going to be the second need later. But now look a bit quick intro on Gerkin. Gerkin is a language that is text-based with some formatting features and some keywords that allow you to use plain language to describe the behavior of the thing you want to test. And a typical Gerkin file looks like this. So you describe a feature, and then you describe the individual, how the software should work in scenarios. And a scenario is also only a description. But then within a scenario, you use the three keywords, given, when, then, and that given sets up some background, then when describes what is happening, what is the user of the system doing, and then is your assertion. So in that case, it's about the game of guessing words, and that describes how this system works. You can probably feed this into ChatGPT and get a working implementation. Now, I'm going to show you how I started to use Gerkin for my projects, and there are these two important notes. I violate basically the recommendation that Cucumber gives on their website, and there's a reason for that. Second thing, in my team, we don't have business people collaborating on these files. It's all technical people who collaborate on this, so I don't have to make it abstract and use plain English language. Also, my users are not humans, they are IoT devices. So yeah, they don't click on a button, they send a message. So I started writing the tests like this, where in this case, so that the first thing that I always need in my feature files is when I write this, I have dependencies to other features that need to run before this specific test is executed. And here is a dependency in the background of that feature that, I have to be run after this other feature. This other feature sets up the device, and I don't want to kind of spend a long time on setting up the state for the device, so I can reuse other tests that basically work as create the mock data. That's not supported in Gerkin. Another thing that I often do is that looks ugly, and I write I write JSON directly into the files. Like, that's something you shouldn't do as per Cucumber, but I want to do it because that's my API. My API is not user clicks with a mouse, but my API is that a device publishes an MQTT message on a topic, and the message is a JSON message. So I really want that to be in my feature files because that's the documentation. It documents what the device should be able to do. I want that in my tests. Source code doesn't look really nice in Gerkin files. It kind of, the editors don't support formatting there, so that's not great. Another thing is that's the last part. Like, I'm going through one long feature, and this is like at the end of this feature. Once this device has sent in the message, we saw here, that's a temperature reading. Then I want to ensure that this message arrives and ends up in our database that we use. And here again, I'm talking directly to the database because guess what? That's a serverless service, and it has an HTTP API. So I don't need to write a wrapper around it, like a node endpoint, a API gateway, whatever. I can talk directly to the database. And so this is also what the web application does. Once the user is authenticated, they have the permission to query this table. So, and the web app will write SQL directly. So I also want to ensure that in my tests. Then there's one, but the point here is then the last thing. Like, then my result should contain magnitude. Oh, sorry, it wasn't temperature here that I sent. It was a geolocation. Anyway, so that I want this magnitude value. It's from impact, I remember. So that's an impact. The device is dropped. How heavy was the impact? And that's expressed as a magnitude of the impact. So I want this to be in my database. However, the time, this is not immediate. Like, if I put something on AWS IoT and publish it on a topic, it then goes through rules and some processing and then gets written into time stream. So there can be 150 milliseconds, 200 milliseconds, or longer between these two things. And in Gerkin, basically that needs to be there immediately. So Gerkin just expects like your tests and your system under tests to be have immediate consistency. So it's not very well designed for having eventually consistent systems. Some smaller things that I want, I have sometimes features which behave differently based on some, in that case it's called context. So the context is the network, how what kind of network the device is connected to, and depending on that, the device sends in a different form of message. So, and under the hood, I still want the same message to appear in a database, and the database and the app doesn't really care how it's stored and what it stores, but I need to document this, okay, devices can send this message or this message, and I want to reuse features. Like, it's kind of the example for scenarios, but because I have this eventual consistency problem, I need to split up stuff in multiple scenarios and then rerun them. So that's why I introduced the context. That I started to hack that into actually Gerkin and my runner, because that's something I also needed. So I've built my own Gerkin-based runner in the last 3 years. And now it was time, like it was just piling up. There were so many problems I saw, especially when it comes to the formatting, that I decided, okay, let's write a new one. So and also changed fundamentally how we write the test files. It's no longer text-based, but I decided, okay, I can use Markdown. Like, that's a language that allows me to write text documents, but I get nice features. Like, I get hierarchies, I can have code blocks, and the best is that this is natively supported in so many editors that there will be no problem anymore if I introduce weird syntax. Like, everything you can put in a Markdown document there's plenty of things that you can express using that. And I'm going to show you a bit what the new things, how I solved them, and how they look like in a Markdown file. So Markdown, for instance, has this thing in the beginning with the 3 dashes. That's so-called front matter. That's basically, you can embed a YAML document in there and can put any kind of metadata in there that you want. I use that, for instance, to express dependencies. So they don't litter my actually the text, but if you look at the Markdown file, that part is not visible, and you just purely see the plain text. Oh, Markdown supports comments. Yeah, that's really nice. It works better for me having these kinds of comments than having them not having comments, because sometimes you want to give some information around why this scenario happens, but to the end user, or if you look at what does this feature do, it's not necessarily that important. So it's a nice way to kind of hide some of the stuff. As I said before, yeah, you can have code blocks, and any kind of code block is supported, and you get syntax highlighting when you do that out of the box. Context is the thing that I showed before. Like, I can use the front matter to create arbitrary, add arbitrary metadata there that then the test runner can interpret to rerun that. And finally, I introduced a new keyword. There's now, before the examples you see, soon, the current position should be. So in the repository, there's the implementation of the Mars rover kata. Mars rover kata is kind of, you have a Mars rover and you can give it instructions like move up, down, left, right, and then you have to think about the Mars that it's on, that it's not a flat surface, but it goes around. That means if you go far enough to the right, your software needs to be, your implementation needs to basically turn the Mars rover coming from the left side again in. So it kind of goes around the Mars. Now, the kata typically you implement it as a immediate consistency implementation. So you have a global array that stores your data, the position, and then you say move right, and then you increment the counter, and then the Mars rover is immediately like 2 tiles further. However, in reality, if you send a signal to Mars, it takes 20 minutes. So I use that example, and the implementation actually uses a promise under the hood. It basically takes the command and then waits 1 second or 500 milliseconds, and then applies it. So in a standard test way, you would call the function move, and then if you immediately read the position, it will have the old position because the Mars rover hasn't arrived yet. And this demonstrates an eventual consistent system, and that's where the soon keyword comes in. So that I can now have a clear separation between conditions that are immediately effective. So if I use then it's still immediately then it will have happened. But if I use the soon keyword now, we see in our test files, okay, this thing will take some time. I think that's for me a really good distinction, and then I can hook into how this soon keyword behaves, because now I can also configure either on the feature file on the top level or per soon keyword. I have a way to configure what this soon means, like how long will it wait, will it retry it, and so that gives me much more granularity in controlling and also documenting the expectation towards how my system should behave or what is allowed to behave. So, and then when we start, that's more or less a side effect of changing the test. The format my tests are written into Markdown is GitHub recently introduced a feature that you can create summaries of your GitHub Actions runs. And these summaries can be arbitrary Markdown. It will be attached to your test run, and you can look at it. And that is the Markdown from the Mars rover test. I've taken that, I got that already, and I'm adding a bit of logging there, like what does the device do, what does it output, and put it into the summary and attach it to the test run. So that's just a benefit of picking that route. So this covers basically my need, and my need one, I need better ways to express my tests. And obviously, for you, there will be many other ways where you see on a daily basis, this one is, that sucks. Yeah? So, and then at some point, like maybe take some time and start twiddling around with what could be done. Can the tool be improved? Like I first improved the Gerkin language itself and had my own Gerkin runner, but then eventually I ended up and hit more and more things that it was okay for me at least to invest more time into writing a complete new test runner. Need two. It's architecture diagrams. It's a terrible, terrible world out there when it comes to architecture diagrams. I need diagrams for architecture because at least my architecture is very complicated, and it's easier if you talk with new people that come into your team about the software that they're going to work on, if you can show them pictures and if you can show like how does an event flow through the system. I personally think a lot in events. I don't really think in components. I have this database. If I explain software to somebody, I always use, okay, this is what happens. This device sends in this message and then like trickles to the system. It touches this database and this one, and that's how I see my systems. So in the diagram for that is really nice. So here, like there's, I tried to build good diagrams using the C4 model, and I'd say I succeeded. C4 model has, it's called C4 because it has 4 diagram types. And I succeeded to some extent on that level, definitely. The context diagram is super easy and basically never changes because your entire system is the blue thing in the middle. That's everything that you are responsible for. And then you draw arrows to your collaborators. Like what are other entities that you don't control where you have dependencies to. And I think that chart, that changes, I think we didn't change it in a year or so. So yeah, it's kind of very static. Then we come to the second level, which is the container diagram. The screen is not large enough. Yeah? So there's more down here, which you don't see. And the point is, immediately becomes clear, like having these kinds of diagrams is a bit useless. Like if I know like where systems are in the system, I can go with you to that thing and I can point to you and say, okay, this is that system because I know where they are. I know the map of this system, but for a new beginner, that's terrible. But it is useful. It's an interesting way to show architecture, because then we can go a level deeper, and for all of these containers, and a container is not a container that like in a Docker container, but an individually deployable system. And within these blue boxes, you then go a layer deeper, where you kind of look at what are the individual functions in there. It's kind of on that level. You roughly have your modules, core API, what do we have there? Then per device something, and then you have individual functions. That's okay, it's a nice diagram. But the big problems were, they were hard to read, but the team liked it. Like that was the feedback. Hey, Markus, this is really awesome. That helps us to understand our software. But then the comments started appearing on these Confluence pages, like this is outdated, like we have to update this, and like it keep piling up. So while the product architecture diagram is good, it didn't allow the team to keep maintaining it. So it cost too much time. So for me, that's a failure. So I'm now looking for ways to. Can we get maybe diagrams that are dynamically generated, that keep themselves up to date? Of course, we developers want to automate everything. And then there are so many promises out there. Oh, just give us your cloud formation YAML file and we create a diagram for you with all the AWS services. It's gonna be awesome. No, it's not awesome. So that's only one stack. So in AWS, and if you describe your infrastructure, you create these YAML files, and and you deploy it, and that thing that you deploy is called a stack. And the number of resources you are allowed to have per stack is 200. Meaning, we have solutions that have thousands of resources, so we need to split them up in multiple stacks, and that's only one stack. So I dump something in there, and I get boxes that are connected with arrows, but they're basically sorted randomly. Yeah? That's not really helpful. So it's completely missing a lot of the knowledge that I draw by hand, like what events are getting there, how does the event look like, I can group them in hierarchies, so that wouldn't work. So I thought, yeah, that's what I said. So I thought, what if we create the diagrams based on our tests? So and there is a way to do that on AWS, which I'm exploring now. So that's a super naive and simple example. But what you can do is like your feature file runs against your system, and you enable tracing, #observability. That means that you track the incoming event and which services it touches, all of them, log basically, oh, I've seen this event from this test. And then after your test run, you ask your infrastructure, hey, please give me the traces from this test run with this ID. And AWS will give you that, and they will tell you also what kind of services you hit and how they were named. In this example, I only use the service names, but they are not anonymous. It's not like, oh, there was a Lambda function, but you actually can know the name of the Lambda function and tie it back to your CloudFormation template, so you can make this clickable, for instance. So that allows me to build now diagrams which are basically tied to the test run, and if I need to explain somebody how this feature works, or how does the webhook work, or how do we send emails, then I don't have to give them this giant tapestry of architecture diagrams saying, okay, if we want emails, then we have to look here and here and here. But we filter out all the noise and can really focus on this specific implementation. What components does it use? And that brings me to the future. So in my head, I'm now like, I'm scheming for, okay, let's bring all of that together. I want a test report system where I have at my fingertips all the executions of all the feature files. I can pick out one. I can maybe filter out the events for this feature, and then see the diagram for a specific feature. And like, I think there are so many opportunities now that we can, if we have a giant system with all these artifacts, we really can much quicker start answering questions that you might have, like, okay, which of our test features uses emails? Yeah? Which, when given an event, I know which components it touches, and if I look at a lot of events, I can see, are there many events from different tests that are always touching one of the similar components? Should we kind of group our architecture different based on the actual usage in the system? So, and in the end, that's like the sky for you is the limit if you start hacking at your own test systems. There are people who make these, and I think more people can make more test tools. And I'm not a big proponent of thinking, oh, it has to be like universal, it needs to be useful for many teams, and we need to be abstract. No, start writing with something that your team needs, that you need, and that annoys you in your daily work. And that's my invitation to you, and I hope you start doing that. So that's what I had, and thank you. Yes, please use the voting feature on the app. It's incredibly helpful for us speakers to get feedback. So thanks for that if you do that, please.
Thank you.
Questions?
Thank you. Yeah, microphone works better when it's turned on.
Yeah.
So now we have time for questions. I think that at least 3 questions, please. I see one hand on the left.
Hi. So thank you for your talk. It was really good. And I guess as you're building out this system, you're gathering a lot of data about what's happening with your quality systems and testing and so on. I feel like I'm riding the edge of a trend with this question, but have you considered how maybe a chatbot type UI over the top could be useful? So kind of like a ChatGPT type thing where you go, tell me about what features do this.
I totally can see the application. 3 weeks ago, I had a call with a vendor who they promised to build a chat tool that knows about your implementation. And these are exactly the questions that my engineers have. It's like I give them a task and like, okay, we want a new transactional email that should be sent out if that new thing happens. And if you put a new developer on that, they are completely lost. They first have to understand, okay, how do we send emails? Like, how does the templating work? And so it's a giant task for them to figure out just by looking at a source code tree. So having a smart UI that's like, okay, I want basically type the function, and then it pulls in already all the components, and then they need a bit of tweaking. That would be perfect. Yes.
Yeah, kind of like a GitHub Copilot for your local test data. And
I don't see why you shouldn't feed in your test data, because kind of, again, then that could provide better context, because if you give the chat thingy the knowledge, okay, it's about emails, it can figure out which components are dealing with email addresses. So, yeah.
Cool, thank you.
Do that, and let us know how it goes.
Hi, Eden here. How do you make to the Gerkin now to don't use DIY, don't repeat yourself? Because I was looking to the way that you use the features, that it seems that you're going to have to rewrite some things if you have more scenarios. And how can you make it to be useful for people who use like APIs that are triggered by buttons or things, like be useful for a larger public?
So I have one example. Like I use third-party APIs from AWS. So basically, you can, if I talk to the AWS SDK, they all follow the same structure, how you invoke certain features there, and you can kind of make that part of your language in your steps, so it becomes generic. Is that answering a bit your question? Okay, a bit. All right.
Hi, I have a small question about there soon.
Yes.
You did show what is inside the comment, like a delay or like repeat. And the third one, I didn't understand the flag. What does it mean? Like delay, you can.
Yeah, okay. All right.
It's understandable. Yes, initial delay tries and delay factor. What?
Delay factor.
Like
That's
flag.
it uses the implementation of in that runner uses a backoff algorithm, and that multiplies the delay. Like there's an initial delay is 100 milliseconds. It waits 100 milliseconds, then tries to check for that. If the check fails, then it will take the current delay and multiply it by delay factor by 1.5 times. So it will wait 150 milliseconds. Try again, and then for the next run, it will wait 150 milliseconds times 1.5, which is 225. So it's a way to control the backoff algorithm, how long and longer and longer you will wait. Or sometimes you want to wait a static amount of time. Like you just want to do it every second, that could also be fine. If I put 1, then it will just be every 100 milliseconds. And I kind of backoff it depends really on the system under the hood, how it behaves. So yeah, typically I want a balance between, usually it's quite fast how data ends up in the database, so I want a short first test so it doesn't kind of wait too long. So if the first try will always be immediate, like it will immediately check it. If it's there, fine, then we're lucky. Then the next one should kind of be very fast because it should be there in 100 or 150 milliseconds. So I don't wait too long. So I think that's always important when you implement kind of these asynchronous waiting for stuff. Don't like blow up the time your tests have to wait for stuff. Yeah. Okay, thank you for the questions. That was amazing.